This is section 2-2 continued. Write a flow proof. In a flow proof, arrows show the logical connections between statements, and reasons are shown below the statements. Write a flow proof to prove the converse of the alternate interior theorem, Engels theorem. We are given that angles 1 and 2 are congruent, and you can see that in red. They want us to prove that L and M are parallel, and we can't just say because they look like they're parallel, okay? They do look parallel. They give us that angles 1 and 2 are congruent, and then we can say that angles 1 and 3 are congruent because vertical angles are congruent. That's your reason, right? So angle 1 and 3, you can see from the diagram that they are vertical angles. Next, in our flow proof, so these arrows are pointing to angle 2 is congruent to angle 3, and that's the transitive property of congruency. So if we look at these first two steps of our flow proof, if angle 1 is congruent to angle 2 and angle 1 is congruent to angle 3, we can just take out the 1 and say that angle 2 is congruent to angle 3. And that's how we get this. That's why we can use this property called the transitive property. It just eliminates the 1. And then that brings us to our conclusion that lines L and M are congruent, are parallel. That's what these two lines mean. So I'm just going to add that. Symbol means parallel. And you should already know this because I've been saying it multiple times, but that symbol means congruent. All right, so lines L and M are parallel by the converse of the corresponding angles theorem. That's corresponding. All right, let's try one on our own. Write a flow proof for the converse of the same side interior angles. Okay, so to do this, the same side interior means that angles have to add up to 180, right? So if we're going to use that postulate, then we can say from that postulate that two of our angles, we'll just call them angle 1 and angle 2, add up to 180 degrees. And what we want to prove is that lines L and M are parallel. So let's just start with a picture. We're going to draw two lines that look parallel because that's what we want to prove. So we'll draw them in a way that they look like they're parallel. And then we'll cut them with a transversal because in order for us to have same side interior, we have to have a transversal. And same side interior would be this angle and this angle. You can see they're not congruent, but we'll label this angle 1 and angle 2. So that's the diagram to go with what is given. All right, hopefully we have space. We have angle 1 plus angle 2 equals 180 degrees. That is given by our same side interior. And we can also say in the beginning that, well, first we have to label another angle. So I'm going to label this angle 3 right here. And I'm also going to make that angle 2 have a double line just to show that angle 1 and angle 2 are not congruent, because if they were congruent, they would have the same marking. All right, now that we have this, we can say that angle 1 plus angle 3 equals 180 degrees because they are a linear pair. And the definition of a linear pair is that the angles add to 180. Okay, so I'm just going to, like in our example on the left, the statement was in a little box. And so I'm just going to put our statement in a box, and then our reason is below it. Then we're going to draw our little arrows to show that connection. And the next thing that we're going to say is that angle 2 is congruent to angle 3. And it's the same reason as the proof on the left that we just did, because if we look at our first two statements with the angle 1 plus angle 2 is 180, did I do that correctly? Let's see. Yes, because the ones can cancel out. So if you were to solve this with the angle 2 would equal 180 degrees minus angle 1. And angle 3 would equal 180 degrees minus 1. So I just said the same thing. Then that means that angles 2 and angle 3 are congruent, and that's also by the transitive property of congruence. All right, and I'm going to box our statement. And then if angles 2 and 3 are congruent, then that means that they are alternate interior angles, right? Like if that means that angle 3 is congruent to angle 2, and if that's true, then by the alternate interior angles theorem, or the converse of the alternate interior angles theorem, lines L and M are parallel. So for our last statement, line L is parallel to line M, and our reason for that is because I'm going to say the converse. The converse of alternate interior angles theorem. All right, that's how we do a flow proof. Now we're going to take this to a real-world problem. Determine whether lines are parallel. The edges of a new sidewalk must be parallel in order to meet accessibility requirements. Concrete is poured between straight lines. How does an inspector know that the edges of the sidewalk are parallel? The inspector can first measure the angles of corners of the sidewalk. Okay, so looking at this picture, since the two 53-degree angles are congruent, he can apply, so let's find those. Right here is 53 degrees, and right here is 53 degrees. And since they're congruent, he can apply the converse of the alternate exterior Engels' theorem to show that the edges of the sidewalk are parallel, right? So this line is parallel to this line, and they are cut by this transversal here. Right? And then if we look at that and we kind of turn our head sideways, we can see that those are alternate exterior angles. And then he proves that they're parallel by the converse of that. What is the measure of angle 1? And what should angle 2 measure in order to guarantee that the sidewalk is parallel to Main Street? All right. I'm going to grab let me see if yellow will show up well. We are looking at angles 1 and 2, and we want to know if this is parallel to this. And we will use the same transversal that we used before. So we're going to be talking about those two angles. And those two angles, if they're parallel, those are same side interior. So angle 1 and angle 2 are same side interior, meaning for the sidewalk and Main Street, to be parallel, angle 1, or the measure of angle 1, plus the measure of angle 2 must equal 180 degrees. Now we need to see if that's true. Well, if we use that 53 degrees that we have in the white, then angle 2 would also have to equal 53 degrees, right? Because those would have to be, all right, the measure of angle 2 is equal to 53 degrees by the alternate interior angles postulate. Actually, there's not a apostrophe right here. And then if that's true, then angle 1 would have to equal 180 degrees minus 53 degrees, which would equal 127 degrees. Only if they're parallel. So if that is true, then the sidewalk and Main Street would be parallel to each other.